Hi everyone, Zach here, and welcome to the final video for section 4A of this tutorial series, Developing a Survival Game. Remember, this isn't the end of section 4, but of our water subsection. In this video, we'll be creating our fully tessellated wave system for our water material. This video and this series have been brought to you by my Patreon sponsors. And in addition, you thought I was doing something different there, didn't you? In addition, at the end of this video, I am releasing a recap video for this subsection. All right, now all of that said, my usual bit here goes, open up your project and let's get started. Hi everyone, and welcome back to the final video for this subsection of section 4, where we'll finish out making our water material. We will be updating our water material in later sections, but for now we're going to get our waves set up and we'll move on from there. I am going to select my character though and move him, or her, or it. Technically it's the mannequin, so it's the mannequin, or it's he. It's not the femikin, which I can't believe that that's what they're named, but whatever. And I'm just going to rotate them around. So we're at the top of this platform, and that way I don't have to deal with the weird clipping we're going to get with the waves, but we'll talk about that down the road and how we're going to handle all of that. All right, so let's stay in our survival game materials water. We're going to create in here a new function, and this function is going to be a bit complex. I am not going to explain all of it, and that's simply because I don't understand the physics that I'm using for this. What I did was I went to Wikipedia, I looked up the formula for how waves in water work, the Gerstner Wave formula, and I converted that over to well, this. I can't tell you how any of it actually works. That said, let's make a start by creating a new material function. So we're going to use our lovely acronym of MF. That time I made the joke. And I'm going to name it the Gerstner Wave, or just Gerstner Wave, not the Gerstner Wave. And I'm going to pop this open. I'm going to pin this in the correct window. I'm going to save everything. And now let's make a start proper. So the first thing we really need to do is we're going to ignore the output node this time. We are going to have to work out how do we get the calculation for Gerstner into our world. Well, the way we do that is we get the world position, and this time we do want it inside of this function. We aren't going to be editing it anywhere else. Now this one is going to be a bit different. We want it excluding our material offsets. So we want excluding the material shader offsets. We want it to be absolute world position still though. And the reason for this is we are going to be creating material shader offsets here. That's what tessellation does. It creates offsets in this case. If we're including those in our calculation, it's just going to keep feeding back on itself, and things get a bit weird looking and can break. So we're going to just leave it at that. We want to exclude the offsets. So yeah, I'm just going to stress that. And then the next thing we want is a dot product, which appends two of our calculations. We're appending the position, the world position, to our calculation. And what we're going to append to it is the direction of our waves. So what we're going to do is we're going to do a function input, and this will be our wave direction. And the way to think about it is each value here, or X, Y, and Z, are going to represent different directions we can move in. They're done by color, so it makes it a bit confusing. We're going to default the X to 1, so we get a nice little red shade there. We're not going to do anything else with that one for now. We are going to come off of here and do a normalize, and this gives us a nice vector we can use. And to make our lives easier, I am going to just go directly from this into a multiply node. Don't worry about what we're going to multiply quite yet. Actually, I'll tell you. We're going to multiply the speed of the wave. I am going to put a reroute in, however, because I'm going to have multiple things coming off of here. In fact, I'm going to have 3 things in total. This is one of the 3. This multiply will be appended to our world position. All right, so we've done this. Let's actually calculate our speed of our waves out. So the speed of the wave is 2 pi divided by the wave length. So, well, we can very easily do 2 pi. So we can hold the 1 key down and hit click, type in the number 2, there's 2, and then we have a pi math function somewhere in here. There it is, pi math. There we go. All right, we're gonna take that and we are going to divide, if I can spell divide right, divide by our wavelength. What is our wavelength? Well, it's a user input. So we're gonna do a function input, and this will be wavelength. And wavelength, unlike our wave direction, is scalar. So remember that wavelength is the distance between the crests of 2 waves. So how far apart are our waves? That's really all this is. For our default values here, we are going to just put in 490. Doesn't really matter. I'm only using 490 in this so I can see when we finish the image out that I put the numbers in correctly, because it'll have a certain pattern of colors. Those colors, if they don't match my prep file, are going to make me panic. All right, with that done, I'm going to come off of here and go straight into our multiply. But I am going to come back down here and put another reroute in, mostly because we're not done with our wave speed calculation. All right. We also then need to control for how gravity impacts upon our wave. So to do that, we're going to multiply in gravity. So there's our multiply. And well, what is gravity? Well, gravity is a constant. Of course, if you're studying this on an alien world, you might want to change that constant. So we'll do a function input. This will be of type scalar. It will be our gravity const. And because on Earth, gravity is averaged out to 9.8 meters per second squared, question mark. I can never remember the actual unit designation on that is. It's meters, that part I remember. We have to convert that over to unreal units. Now, unreal units are centimeters. So 9.8 is 980 unreal units. I'm going to use 980, and that is not a random number. That number has meaning. And then we have to account for the time as well. That's part of the speed. The distance between each wavelength is accounted for time. So the way we do that is we do square root. We take the result of the square root of our gravity multiplier here, and we multiply that by time. So we have another multiply node, and then we are going to do time. All right, I'm explaining this a lot more than I think I should be explaining it, because probably anyone with a physics background is just cringing at all my explanation. Speed of waves. That's all this is. That's the speed of the waves right there. Right. With speed of waves done, and we have our dot operator now done, we are going to take away from this calculation the time. So we're accounting for time. So it's going to be subtract, and then we're going to subtract that from there. There we go. Just going to try to line this up to be a bit nicer and neater. Oh dear God, I see how close to that input node I am. I need a lot more space. Right. This is where things get normal. And this one took me a bit to work out how to do, because I didn't know something about Unreal or math. I think I found it on a forum post. Can't remember where I found this. I found it ages ago, back when I first did this. The next part we have to do is we have to get the cosine of this. And this is where things can get a bit, well, wonky, to say the least. So we are going to pull from here to get cosine. Now, as I said, there was a part of this I didn't understand in Unreal for a while, and that is that it doesn't use the normal period used in maths. The normal period used in math when you're doing a sine function is 2 pi r. Or sorry, it's 2 pi, not 2 pi r. And 2 pi is roughly 6.2. Sorry, I'm just going to copy and paste the number in. It's 6.283185. So if you go to a calculator and do 2 pi, you should get something like this. This is the most I can get into Unreal. But notice it changes how that wave is moving, the speed of it. We then need to control for our Z value. So we need control really for the height of it. And what we're going to do is we're going to pull off of here. And we're going to do a multiply. And then we're going to select all the nodes real quick. Actually, I'm going to put a reroute in first because I know I'm going to need to come off there again. We're going to select all these nodes again and just keep moving to the left. And we are going to do a vector 3. And because we need a control for our Z, what we do is we open this up and we change our blue value. So we have a value of 1 there. You can see our movement there coming through. If you plug that in, we get a blue movement through instead. That is what we are looking for. All right. So I'm just going to tuck that under there. That's controlling for our Z axis. Next, what I want to do is I want to adjust for the wave height itself. That's what we're starting to do here. So I'm going to do a multiply. And I am going to do another function input, which is... Sorry, I just realized something about these. I think they're alphabetical order. Wave height. This is a scalar value. And as a dummy value, I'm going to use a wave height of 2. And I'm just going to plug that into there for now. All right. So let's go over to our result now. This first result will be our offset. Like I said, we're making offsets. So this is that first result we have. And for now, what we're going to do is we're just going to come into here and plug into our offset. And you can see that we have this sort of wave-like motion of light here. Now, it isn't perfect. It isn't right, in fact, actually. We have to do some other things. We also have to consider that we need to adjust for our normals. So we are going to do an adjustment for our normals. We're going to do another output. And it's a function output, and this output will be our normal. Like I said, we're going to update our normals. And the way we're going to do that is we're going to come back over to our normalize here. We're going to come off our normalize. Actually, we're going to start before our normalize. I lied to you. We are going to come down to our... Oh, we have a lot of steps for our normalize, actually. So we're going to start down here. We have our sine. We now need our... Sorry, we have our cosine. We now need our sine. So we're going to get a sine node. And again, we have the same error where our period is off. And we're going to, again, use 2 pi as our period. So 6.2831 whatever. I'm going to come off this subtract right here. I'm going to put another reroute in just to make my life a tiny bit easier. And so you guys can more easily keep track of everything that's going on. And I'm going to pull from this into our sine. And notice now we have that white pattern. All right. I am going to leave this just for a moment because we have more to do down here. But I want to go up and work on our X and Y mask for adjusting our normals. So I'm going to just... Unfortunately, we are going to have spaghetti. I apologize in advance. I'm going to pull up and type in multiply. I am going to put another reroute here because, again, I am going to have more things coming off of this down the road. And from our multiply, we'll clean up the spaghetti in a minute. I'm going to tell you the truth. We're not going to clean up the spaghetti. I need to account for the wave height multiplied by our speed. So I'm going to take from our wave height here. I'm going to move that to the right, put a reroute in here. So from our wave height, I am going to multiply into our speed. So I'm going to do a multiply node. And wow. Multiply node. Gotta get it in the right spot apparently. Put that in the B value. Not that it really matters because principle of multiplicity, but I just prefer it in the B. That's just my thing here. This is my third one I mentioned. We're going to have 3 coming off of here. That goes right into the A there. And we're going to put a few reroutes in. Or one reroute, really. Going to line those back up. There we go. And we now have our wave height being accounted for in our speed of our waves. All right. In fact, actually, I want to put a reroute here too, just so it has some symmetry. And because I'm weird like that. All right. We're going to take this resultant value and we're going to do three things with it. The first thing we are going to do with it is we're going to use it to help to control for our mask here. So I'm going to come off the result of our multiply and plug it into our XY mask that we're creating. So there we go. And I said we're going to do three things, so clearly I'm going to put a reroute in there, right? Again, trying to keep all this lined up. It gets really messy. That's why I'm doing all these reroutes. All right, from our multiply, I am going to multiply again. And this time I'm going to do it based off our normalize. So we're going to have 3 off of this one as well. So that's the second one. So I'm going to do another multiply node. I'm just going to duplicate that in. We're going to multiply A from our last multiply. And we're going to come off of here for the second thing we need to do and plug into our B. Sorry for being so zoomed out. Hopefully you can read this. We'll line those up. And then we're going to create our mask. So we're going to zoom back in and we're going to just do a component mask on the R and G. So this will mask X and Y. All right, let's just move this upwards a little bit. We are going to append this to another node. And we're going to get a nice blue shade here. But this will be our normal. In fact, let me just grab all these and start moving them upwards because I know I need a little bit more room. All right, so what are we appending to this? Well, we're going to append our sine to it. So we're going to come off of our cosine, sorry. We're going to come off our cosine here and do a multiply. And what are we multiplying into our cosine? Well, we're going to multiply into our cosine our sine. Oh, wait, no, sorry, not our sine. I lied to you. I completely lied to you. We're going to multiply in our counting for our wavelength by our time. So this is number 2 of 3 that are coming off of this one. There we go. Fortunately, again, there's no way to make this neater. And then we're going to divide this by something. Well, what are we dividing it by? Something we haven't done yet. And that's actually going to be the third part down here. We then need to divide or multiply that. Sorry, I said divide. I misspoke. I meant to say multiply. We need to multiply it by something. And that's what we're doing the division down here for. So we're dividing down here. In fact, actually, I'm going to break this just for a moment. I'm going to put the reroute into this part. And then I'm going to come that way. There we go. You know, I'm still not a fan of how that turned out, but whatever. There we go. Getting closer to how I want this to look. So what we're going to do is we're going to divide here by the steepness of our waves, except for this is our B value, not our A value. And that is not an optional thing. That has to be in the correct order or things get wrong. And so what's our wave steepness? Well, that's a scalar input that we're going to have control over. So we're going to create a function input called wave steepness. It is of type scalar. I'm just going to minimize that, plug that into there, and for our default value, what do I have in my prep file? I think I put 0.3. So wave steepness, what is wave steepness? It's really, at the end of the day, amplitude. So what is amplitude? Well, if you don't remember what amplitude is the measure of a wave from the highest point, the peak or crest or whatever term you want to use, to the lowest point known as the trough. So that is the steepness. How steep is our wave? How much does it measure from top to bottom like that? All right. So we now have our amplitude. We have our frequency, which is our wavelength. We have height. We have basically everything we need to control our waves. We're going to take this divide and plug it into our multiply up here. And we're going to put another reroute in because God knows that we have more to do with this. All right. And I'm just going to start lining things up down here again because it's starting to get messy again. With that done, I'm just going to move that to the right a little bit. I am going to invert this value. So I'm going to do a 1 minus node. And I'm going to append that into our B. So now we have that nice blue shade there that we're looking for. You notice it's changing tones just slightly with the waves. That's what we're looking for. We're going to have a little bit more to this, I think, down the road. Oh, it's just my screen space. But that is the correct thing that we're looking for. And this is going to adjust our normal. So we're going to use this to change our normals. So based on where the waves are, our normals need to change. That's this. All right. So now that we've done that, the next thing we need to do is really kind of take care of the rest of this. And this doesn't really work. So what we're going to do is we're actually going to take from our multiply and we're going to subtract. This is the end, by the way. The subtract will go into our output here. And what are we subtracting? Well, we're subtracting all this math that I don't understand around our sine for our wave formula here from all this other math that we're doing. Like I said, I don't understand this. I'm guessing at how to explain this. Wikipedia, ladies and gentlemen, Wikipedia. That's literally where I got the formula from. So what we're going to do is we are going to multiply this, and I don't know why. I can spell multiply, right? By our wave height. So we're going to come down here. There we go. And then we are going to multiply this by our sine. So I'm actually going to come off the sine because that's going to be our A. Not that it really matters, but I'm trying to keep it in the same order as the formula. I'm pretty sure I'm editing out the pauses in my speech. If I haven't edited them all out, some of that's me looking at the prep file, some of that's me actually looking at Wikipedia to make sure I have the formula right. And we should have this nice little sort of... Ooh. I don't have the right color. That's terrifying me. Give me 1 second. Sorry, I got terrified for the wrong reason. I'm one node away from where I think I want to be. So I'm going to actually minimize that one. It's not the one I care about. I want another multiply. This is the one I care about. We're going to plug that into the B. And in our A, well, I said we're going to have 3 things coming off of this normalize. That's the third one. Boom. And just, again, to make this a bit easier to follow. Because, yeah, and enjoy working that one out. That goes there, and it's red. That's the color I wanted to see. Thank you. I am going to grab all these nodes. I'm going to move them slightly that way. Grab that node, move it slightly that way. All right, and I'm going to plug that into there. And I'm going to have this nice, lovely shifting color. This is exactly what I expect to see. I'm seeing pink, orange, red, blue. Yeah, these are the colors I am looking for. Oh, by the way, the actual Gersnter formula is all of this bit here. Literally. Well, minus those 2 parts. That's the Gersnter formula. So this is the actual Gerstner wave formula that we've done. As I said, this is really, really complex. I'm just amazed at the math behind this, but this is the Gerstner wave formula. So what are we going to do with this? Well, we are going to plug this into our material, our water material. Let's go to our water material, not our instance like I just did there. All right. And this is where we move our tessellation multiplier down because we need a lot of room. I am going to skip through part of this. I'm going to show you once, and then I'm going to have you do the other ones. And that's just the setup. We'll come back after the setup. So do a material function call. So this is the first thing you're going to do. You're going to do this a total of 4 times. But do one. Just do one for now. It is going to be our MF Gerstner wave. There we go. Right. I am going to just cheat for the moment and do our gravity first. Because that's the only one you don't have to replicate is gravity. And we are going to use Earth gravity for now, which is 980. And I'm not going to give it a min or a max. It is 980. I've put it all the way over here because this is the only one I'm going to use multiple times. All right. the rest of these, I am going to convert them to, I guess it isn't alphabetical like I thought. I am going to convert them to the parameter. So our wavelength, I am going to call this wavelength 1. The number matters, by the way. And I'm going to just give this a value of 450. I think that's what I put in the test file as well in the material function. Was it 490? What did I put in here? 490. We'll go with 490. All right. Then I'm going to do my wave height, promote to parameter. This is wave height 1. The reason why the 1 is, and again, we're doing this 4 times, is because there isn't just one wave when you're looking at the water. There's waves that hit each other, move against each other, move in different directions. That's what we're accounting for here. What was my wave weight? What did I mean by wave weight? I think I meant to put wave... Where I put wave weight, I meant to put wave height. I am sorry about that. I just caught that typo and clearly have confused myself a bit here. All right, so this should be wave height, not weight. And I had in here a height of 2, so we will default this one to 2. All right. Then comes our wave steepness, and this will be wave steepness 1. Again, the number matters. And I'm going to default our wave steepness to, what did I put in here for the first one? 0.3. All right. And then comes the fun one. Going to promote this to a parameter. And this is wave direction 1. And again, I think I just put this in value of 1 on the x-axis. I did. All right. So that is what you're going to replicate. You're going to make this setup 3 more times. You're going to use whatever numbers you want. I'll show you my numbers in a moment. I'm going to pause the video here, and I'll see you in just a moment. All right. Now that you've done that, you should have a horrible thing that looks like this, where we have our gravity constant plugged into all of them. So the numbers I used for wavelength, I'm going to use in order of wavelength, height, and steepness. So the first one for wavelength, it's 490, 2 for height, and 0.3 for steepness with direction at 1 in the x value or the red value. That's the same as what's in the in the material function. For the second one, the wavelength is 450, height 2.3, steepness 0.2, and my direction is 0.3, negative 0.1, 0, and an alpha of 1. I'm not sure why I've done the alpha there. For our third one, the length is 300, the height is 1.2, the steepness 0.75, with a direction of 0.4 by 0.2 by 0. Again, these are just placeholder values. We will be changing these, but this is just so I can see all 4 waves very quickly when we go onto the main map. For wavelength 4, it's 500. For height 4, it's 2.6. Steepness 1.22 with a direction of 0.4 by 0.2 by 0. Notice I don't do anything in the B ever because that's the Z. That's not a direction. I mean, you could see what happens when you plug something into there. It gets fun. All right, so we have to combine these. We have to combine the offsets first. So let's do the offsets. And the way we do that is you do add. And we're going to add offset on the first one to the offset on the second one. And we're going to repeat this process down here with 3 and 4. So I'm just going to duplicate the offset or the add node. So we're going to take offset from that one and offset from that one. So we've now added our offsets together. We're going to take these 2 offsets and add them together. So add and add. And there it goes into the B. So we take the offsets from each pair. So 1 and 2 is a pair of 1. Add them together. 3 and 4 are a pair of 2. Add them together. And then add the 2 pairs to each other. And we get this. This what we'll be using for our actual world displacement. So we can come from here and pull up into our world displacement. All right. And the fun should start when the shaders are finished compiling. If I've done this correctly, we should see some weirdness over here. So there's the weirdness. We've done it correctly. It's tessellating. And it's tessellating based on a wave. That is a wave. It just is weirdly looking, kind of the jelly blob thing here. Don't worry about that too much right now, though. Right. Next comes the trickier part, our normals. And so what we're going to do is we're going to pull off the first normal here. We're going to type in blend angle corrected normals. And we're going to take off the second one, and that's going to be our additional normals. We're going to duplicate this node up here. And the first normal will go into there because I started with 3 and 4. And the second normal will go into additional. All right. And then we need this node a third time. And because I'm now getting really close to where I've designated my end of my nodes, I'm going to move this to the right a bit. And just keep moving this to the right just a tiny bit. All right. So I'll just move these down as well. This normal will get, our base normal will get from that corrected. And from our additionals, we'll go into that one. Like I said, it's a bit complex. It's a bit messy. But this is how we're adjusting for our normals. And, well, we can break this now. We can then duplicate this node up here. We can put a reroute in. Yep. We're going to plug that into our base normals. Actually, I lied. We're going to plug this into our additional normals. Yeah. This will be our base normal. Not that it matters too much. And we're going to take from this and go into our normal. And now, to clean up the spaghetti a tiny bit, we're going to put some reroutes in. This step is optional. This step is just to make this a little bit easier to read. Because, yeah, I realize how complex this is. All right, let me just name this real quick and or comment this out real quick as our waves and tessellation with normal adjustment. All right, I am going to pause the recording here for a moment. So I'll pop back up somewhere else inside of our materials. I just want to see if I've forgotten anything. So now that we've done that, let's go back to our main map and take a look at what's happening here. Let's wait for the shaders to compile. All right, with them compiled, we can now see these horrifying, fast-moving waves. But hey, we have waves. That's a nice thing, right? Right. Now you can probably see why I moved the camera a bit. But you can see there's multiple waves in there. They're coming at different speeds. They're doing different things. They're all kind of, yeah. They need to be cleaned up a bit. So let's take care of that cleanup as quickly as possible. I'm not gonna fiddle with the numbers. You can play around with them to see how these numbers work. I am just gonna give you what my values are. So I'm gonna start with my wave direction 1. Wave direction 1, I want to be a nice yellow shade. And so I'm gonna have it at 0.75. You can now see there's been a change slightly in the background there. And 1. You can now see that one wave is moving in a slightly different direction than all the rest. It's a bit harder to see with a B value of -1. And this is to control the height. You can see one of those waves is very different. I'm going to stay on wave 1 for now, so I'm just going to activate all my 1s. And for my wave height 1, I'm going to go to 2.3. For my wave length on 1, I'm going to go to 600, so it's a slower wave. There's more space between them. For my wave steepness, I'm going to go down to 0.2. And you can see there's been a bit of a change on one of the waves. For my second wave, I am going to change this value to... Oh, actually, I'm not going to change this value. Apparently, that is the value I've used. Cool. For wave height, well, it's a little bit too big, so I'm going to go to 1.5. Again, we can see some differences there. There's 2 that were way too big, that is, together. For my wave length, I am going to make this a very slow wave compared to the others at 1240. For my wave steepness, I am going to make this a bit steeper at 0.5. All right, you can see there's some changes in the background there. For wave number, hang on one second. I forgot to label this wave 4. So why is there only 3 waves suddenly? All right, with that done, I'm going to let it save. I'm going to go back to the main window now. For wave direction 3, it might be the actual value I have. No, it's going to be 0.5 by 0.2. Well, everything else is the same. For wave height 3, I will leave it at 1.2. For wave length 3, I will leave it at 300. And for wave steepness 3, I will set it to also be to be 0.3. All right. Now for wave direction 4, I'm just going to select this. I'm going to set it to, I'm going to leave it at these values, I guess. Cool. All right. For wave height 4, I'm going to change this to 1.8. All right. I am going to change the wave length to 2500. I'm going to double check something in a moment. And the wave steepness to 0.5. There we go. It was that one that was doing the weirdness. So now we have a nicer sort of wave pattern going on here. I'm going to save this out. Again, remember, it's going to look a bit weird here because we're not looking at a massive open water version of it. If you want to see something really freaky, there you go. You can see it's a bit jagged there. But we now have our water set up. So that takes us through what we need to do for this section of section 4. In the next section, we will set up, or the next part of section 4, we will set up our materials. That said, or our landscape materials. This series and this video have been brought to you by Patreon sponsors like Hanas, Rian, Galois, 1Volt10, Quad Menson, and Connor. If you've enjoyed setting up your water and doing Gersner wave formulations, or watching me struggle trying to explain basic physics, not sure how basic it is actually, then go ahead and hit that like button down below. It really does help the channel out, and it lets me know that I'm bringing you content that you enjoy. And if you want to be here when we start working on our landscape and import our island height map, make sure to hit that subscribe and notify icon. All of that said, I look forward to seeing you in the next part of section 4 and hope that you have a wonderful day.